Okay, so the next, just recall a bit based on your capacitance. So the earliest is based on your some calculations that Miss us, I think we did together, not mistaken me. Okay, so this is where we have these equations. Just have a look on these equations. Okay, in these equations, they shows you based on your capacitor. So every time when they are highlighted to your capacitor, not necessarily we always have one plate. Okay, they can have a multiple plates, as Miss explained it last time. Okay, they can have a multiple plates. Okay, so in terms of multiple plates, they can ask you to calculate how much is it the capacitance. So when you calculate, make sure you take note the equations of the n. Some of the equation they just wrote, we don't have the n because they only stand for one capacitance. Unless they highlighted to you many capacitance, then you must take note based on these equations. Okay, and divide based on the distance they given to you. All right. And also we have go through one more equations. Is it the same equation? Okay, and one more, this is a simple equations based on the charge. How they calculated based on the charge. Remember when they said capacitance, what the function of capacitor? Uh, mm, how to say? Maybe Miss can ask you how to define a capacitance. What the definitions of the capacitor? Determine or define for me what is the capacitance. So most of the thing, the key point that you need to take note. Capacitance is related to the storage energy. So this is the one that you need to take note. Where is it? Okay. Take note, the purpose of the capacitance is to store electrical energy. This is the key point. No matter any explanations, they ask for your capacitance, always highlighted this point. Okay. So let's go on with our slides here. The one we stop. Okay, we did the examples. Maybe I asked you to do the example, one of the example, I leave it to you. But Miss can't remember right now. Okay, now mind we go on with this part. Okay, have a look. That shows you based on capacitor connected in a parallel. Okay, what they mean with a parallel? They always have the way they connected a components, or we said uh, elements connected. Okay, in the circuit. Okay, so when I said circuit, of course you already know right now what is this. Circuit always consists of a source. We have resistance. Can have other components, electronic components. Okay. So when they say capacitance, with the capacitance, we also can build up a circuit. Okay, so the one you're looking right now on your slides, okay, just have a look on your slides here. You ignore other parts based on the wording part, just ignore first. Just have a look on the image. Just have a look on this image. Okay, so this we call as a circuit also without source, but usually we need to have a source to complete the circuit. Okay, in terms of this circuit, they shows you have a capacitance. Capacitance 1, they wrote you as a capacitance 2, then they highlighted as a Cn. Okay, actually the one they highlighted to you as Cn, actually they have a multiple capacitance, but they not draw all the capacitance here. So in a shortcut way, they just highlighted to you Cn. Okay, so we don't know whether it's a capacitor number 5 or capacitor number 6 or capacitor number 8 or capacitor number 10. Okay, that's the reason they highlighted as a Cn. Okay, and you see the arrangements of capacitor. Excuse me. Based on the arrangements of capacitor, we say as a parallel. Even the titles here, they already write for you parallel. Capacitance connected in a parallel. They always have two-way they connected. Usually they have two-way connected. One we say series, one we say parallel. Take note, always have two-way. Okay, one part we say series means the connections will be in the same line. Okay, example, in the same line. So this is the one we call as a series. This one is explained later on. And then this part on this slide we said as a parallel. So parallel means you have the elements or the components of the capacitor in opposite. Okay, you have the components A, opposite of the components A, you have one more components we call as a capacitance also, we just put label as a B. Okay, opposite of the components, opposite of the elements, we have one more components. Okay, we say component C, capacitance. Okay, so these arrangements we call as a parallel. At the same time, okay, maybe some of you have a look on the word, this word, SHUNT. So do anyone see this word before? The word shunt, S-H-U-N-T. Do you see this word before? Okay, all right. Okay, usually for our EEP, we always use the terms parallel. Okay, we're not going to use the word shunt, but sometimes maybe in a different, how to say, in a different module, maybe you will learn about the shunt concept based on your circuit diagram. How does it look like? They call as a shunt circuit diagram. Okay, but so far, I think you can ignore this one, but just for your information, okay, the word parallel, sometimes they also defined it as a shunt circuit diagram, okay. At, the, at this point, you can see your components arranged parallelly. They highlighted C1, they highlighted C2, the next one they point out as a CN. At the same time, each capacitor, they have their terminals. What I said, I always said as a lake, okay. So what I said lake means terminal, okay. So you have A terminal, you have the B terminal. And every time the way they connect it, they always specific for you the polarity of the negative, okay, where the point of the positive, where the point of the negative. For all the components, they always have the polarity, but some components they not specific the polarity. Take note, most of the component they will highlight it to you the polarity positive, they highlight to you the minus polarity. So example for your capacitor, just have a look on this image. They just put negative charge, they just put a positive charge in terms of the charge. So from here, you will know the current flow will be start from this point, okay, because all your positives are going towards these directions, okay, and all the connections at this point will be connected to the negative polarity, okay. So just take note about this part here, positive with the negative, okay. So when they highlighted a capacitance, they have two symbols of capacitance. One capacitance, they only shows you this diagram. It's not a battery, they have a straight line, okay. Just have a look on this image, okay. And one different is a capacitance also, but they will show you in terms of this symbol. One terminal straight line, the next terminal they have a curve a bit, okay, they have a curve. So you have A terminal, you have the B terminal. This also we call as a capacitance, this also we call as a capacitance, okay. The reasons this we have, they always defined a polarity. They have highlighted directly the polarity of the positive, and also the curve they already highlighted it, either it's a positive or negative polarity. But in terms of this one, we can't say exactly where is in the positive polarity, where is the negative polarity. But based on your figure they given to you, they give you some key hidden. What they hidden? Based on the charge, positive charge and negative charge. So when they highlighted to you a positive charge, it means right now you need to know your supply is connected in these directions. Positive supply, the next is connected to these directions. This diagram is connected to positive polarity. This one, the negative connected this at this polarity, the source. So it means your current flow, okay, or the voltage drop at your capacitance, okay, they're going to store it based on your energy, based on your charge. The flow will be in this direction. The current flow will be in this direction. Positive, positive, positive. Okay. At the same time, you have a look on this diagram. It's look messy. Wait. Okay. Maybe I will drag your time 10 minutes. Okay, maybe we finish up 6:10 if possible. Okay, so on this diagram, you can see they highlighted to your positive charge, they highlighted to your negative charge. At the same time, they use the word C based on the capacitance. At the same time, they highlighted to you the word V. It means the voltage going to pass through your capacitance. Take note, positive charge, negative charge, they specific for you the capacitance value. Okay, at the same time, they highlighted to you the voltage. Okay, why we need to have the voltage here? So we have a look on the equations. So all the information they highlighted in the symbol, or all the information where they highlighted in the figures are referring back to your formula. So this is the one I call as a formula equation. So have a look on the first equations here right now. The first one, they point out for you Q1. Okay, the next equation they highlighted to you as a Q2. The next equations they highlighted to you as a Qn. So at this point, you may have a look where the point is specific for you, the Q1, or we call it as a charge, this one. At this point, okay, at this point, they have a calculation based on the capacitance times with the voltage to define the value of the charge. How much is it the charge will be? Same goes to your Q2. They have their own way to calculate where capacitance, the value of capacitance times with the voltage to get the unit of the charge. That means the value of the charge is how much. Same goes to your Qn. Take note, Qn, the reason they put n because you can have multiple capacitance. Okay, but we can't specific which number is it. Maybe number 10, maybe number 8, maybe number 12. Okay, so that's the reason they're using the word n here. Okay, and the flow they calculated is the same thing. Capacitance times with the voltage. At the same time, have a look to define the total of your charge. This one, the first one, they specific based on the capacitance. The second formula, they specific based on the total charge. So they also can ask you to calculate the total charge. They already specific for you QT. Maybe in your slide, they not highlighted to you the word T, but usually they will highlight to you the total. Q, they put T, small. Sanskrit, in this form, they will write T, the small t. So total charge, you need to calculate all the charge that you get, but not in terms of the series, not parallel. What I may say, sorry, in terms of plus, equations plus. Q1 plus Q2 plus so on until you have the Qn. This is the process that you need to calculate. Okay, and the next one, have a look. Okay, the way they calculate it is the same thing, but to define the value it. Okay, based on your total. When you want to find the total of the charge here right now, you're going to find based on this equation. Charge times with the voltage. Actually, the one first and the second one is the same thing actually, but the third one, they shows you adding. They just add each of the capacitance. Okay, so at the end, you can find the value of the charge. How much is it the charge will be? So this one, capacitance, take note, this is based on the charge. This is based on the capacitance, or we call it as capacitor value, the value of the capacitor. So at this point, they shows you the flow, okay, or the method, how to say, the technique they calculated to find the total capacitance, CT. Okay, they using the system or the equations, the formula they use is plus. Okay, this one, this means A plus B plus C. This the equation should be for your parallel capacitance. Okay, let's have a look on the next slide. Okay, next slide is the same thing. Means not going to repeat back. Okay, this is the one you can see. They always specific for you QT because the previous one they just miss out the T here. Actually, we should have the T, QT. So this one, it means you need to calculate the total charge of the circuit diagram. How much is it? Okay. You may have a look at these equations later on. Is the same equations one is explained in the previous slides. Okay. Have a look on this part. Okay. Have a look on this. This is where we call as capacitance connected in the series. Just now in the parallel, now we call as a series. So what they mean with the series? Okay, series means all your capacitance will be connected in the same connections. We defined it connected in the same connections or in the same direction. I say it's in the same connection or same direction. Okay, have a look right now. You have the C1, you have the C2, you have the Cn. C1 until Cn, the numbers we're not sure how many is it, okay? At this each point, we have the voltage, It's the same as your parallel, okay? But the only thing that you can find the difference between the series with the parallel, the way they arranged the capacitance, okay? So take note, parallel means you have the opposite, the elements component will be in the opposite. Unless they specific for you the series, the connections will be in the series, in the same connections, okay? Have a look on the formulas here. In this formula, they shows you how to calculate your voltage. They're going to plus each voltage. V1 plus V2 until Vn, you get the voltage. Alright. At the same time, you want to find the value of a charge. The value of the charge is where you need to have charge divided by the capacitance. But each time you need to have a divisions based on the charge divided by the capacitance. Charge divided by the capacitance based on the capacitor, how many capacitor you have. At the end, to find the value of the capacitance or the value of the capacitor, you're going to use a parallel technique. Usually this technique we call as a parallel, but for capacitance, for the series, we're using this technique. Okay, you're using this technique, alright? Because later on when Miss teach you based on the resistance, then you can find For the parallel, they're using this technique for the resistance. Okay, but in the capacitor, for the series, we're using this technique, this formula. Okay, 1 divided by 1 over C1 or C2. In the same time, sometimes they also can write this equation. Okay, example, we only have two capacitance. Just take note, we only have two capacitance. So this C1 and C2. When I ask you to calculate the total capacitance, you also can come out with this equation. C1 times with the C2 divided by C1 plus with C2. It's the same concept. But those not familiar with this equation, you're not sure with this equation, go on with these calculations. Okay, go on with these calculations. Usually, the way they write, they also can write 1 over C total equal to 1 over C1 plus C2 plus C3. Okay, the same thing after they converted to find the C total here. Okay, so it means, of course, once you calculate everything, 1 divided by the total answer, what you get here. This will be your series calculations. Okay, have a look at the same formula they wrote in these slides. Okay, this is the one I showed to you. This is the one equations. Unless you can't simplify, don't go on with this calculations part. Sometimes you have multiple capacitance, not only two capacitance, you can have more than 5 capacitance. So you're not sure how to simplify, don't do this. You go on with the manual. It's okay, you do it with the manual. Okay, so let's see. You have, okay, the one you have right now in your example in the capacitance quite easy. Miss can say it's very easy because I just go through first. Okay, calculate the equivalence capacitance of two capacitor of 6 micro and 4 micro, which is connected in a parallel and series. Even the answer they already highlighted to you. Is it how much 10 with the 2.4 micro? But we're not going to do this one, but I'm just going to show you the technique how they have in a parallel and series. Take note, when they highlighted in a parallel, you need to take note. So the value they given to you, 6 micro with a 4 micro. They not shows you any circuit diagram. They not shows you any circuit diagram. So they only specific for you. The first one is parallel, the second one in the series. So you need to know when they specific for you the parallel means your diagram going to be in this form. It means 6 microfarad. Okay, parallel with this one example, which is 4 microfarad. Okay, so in terms of parallel, your equations that you need to define is means C1 plus C2. You get the answer. It means 6 micro plus with 4 micro, you get the answer, what the answer will be. So that's for your A. For the B, they ask you in terms of the series part. So when they ask for the series, your diagram will be in this way. The connections will be in this way. So this will be C1, this will be C2. Okay, we specific the value first for parallel. We did this is C1, right? 6 micro. I'm going to define the same value 6 microfarad. The second one will be 4 microfarad. Parallel, remember the equation. So just now I informed you the equations will be excuse me, 1 over C1 plus 1 C2. Or you also can write as this 1 over 1 C1 plus with a 1 C2. Excuse me. Okay, now you can substitute your value directly into the equations. 1 over C micro plus with 1 4 micro. Okay, you will get the last answer. Can anyone calculate and define for me whether you get this answer or not? Use this technique and calculate. Do you get the answer 2.4 microfarad? For the C series. Can anyone calculate? Uh, 2.4. Okay, only one student responded to me. How about the others? Just substitute for your series one, this one. Substitute the value. 1 over t, which is 1 over t, C1 plus 1 over C2. Substitute the value 1, 6 micro plus with a 4 micro. Okay, don't forget this is 1 over 1t. So when you bring up to the next part here. So it means 1 over 1, 6 micro plus with a 1, 4 micro. Quite easy for you to calculate. You get the last answer. Anyone else can give me the answer? Is it right answer? The one you have in your slide. Is it right answer? Okay. How about others? I only have to respond. Okay, since they have no response, all right. Okay, so the next one, okay, the next one also quite easy. Okay, so Miss now going to focus on this example. Later on, I want you to do the examples here. The one you have in your slide, I want you to do the examples. Okay, try and error, check whether you get the answers or not. Okay, so before we proceed for the next part, based on your other example calculations, based on your formulas here, we go on with the one calculations here, based on the capacitance series and parallel. Okay, I will continue under capacitance. Okay, Miss will write under capacitance. Have a look. Okay, we still have 5 minutes, but I will take your time 10 minutes extra if possible. Okay, so I want each of you to calculate this one. Okay. That here. Don't have. Okay. Okay, so due of time purpose, I just want you to calculate. Okay, I'm going to put a value at this capacitance. I want you to find the total value of this capacitance. So I'm just going to specific here right now. So we go on with the same unit micro. So not necessarily every time your unit will be in a micro. They can be in a nano. They can be in a picofarad. Okay. 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 This means give you on the spot. The calculations on the spot. Okay. So I want you to calculate. Okay. Calculate the total capacitance. or we say capacitor. The CT is how much? Okay, I don't want the last answer. Miss want the steps how you simplify to get your total C. That's all. Okay, did of the time means not ask you to calculate based on the voltage, based on the charge. Just define for me how much the total capacitance that you can find from this schematic. Have a look carefully. So can you do? You may have a look on your slides, okay? You may write the formulas for your series. Okay, how is it works when it's series, how is it works when it's a parallel. Can you try? Can you try? Okay, how about the others? Can you all try? Okay, all right, only few of you respond. Please understand that now it's 6 p.m. Okay, just your time, 5 or 10 minutes of your time. Okay, never mind. So let's say I'm not going to give you the answers here, but I just want to point out a few things here. After that, we can end the class. Okay. So have a look. This one actually they have 6 capacitance. Okay. Actually I should not write as a Q. I should write as a C. This one actually the charge. The one Miss wrote here as a charge. I should write as a C. Okay. So in this circuit we have 6 capacitance. Okay. And if you have a look, each if you want to divide the sections. Example on this part you can divide. Okay. It means this one we divided as a one section. Okay. So I'm going to put as a A. Okay, and the next one I divided to the next section. It means this one. So this should be the B sections. And the next one I divided to the next sections where I have defined it as a C. So I have A, B, and C. So for the section A, you may have a look. The way they connected the capacitance is a series. Okay, so when it's series means I need to know what equations that I need to use, right? So example for the series equations, I need to use this formula. 1 over CT. Okay, have a look back your equations, this para. You series, the equations, how did you find out the equations? This one. So go back here. So it means you need to know based on A, you need to have 1 or 50 micro plus with a 130 micro. Okay, but remember, you want to find the total for A, total for A. So total for A, of course, you're going to do back 50 micro plus with 30 micro capacitance. So you will get one answer. I'm not going to specify for you the answer. I leave it to you to calculate. This will be your last answer. Okay, example, your last answer, Miss just wrote A, B, C. Example, just an example. I just put A, B, C. You define for me what is it the value will be. Once you're done for the A, the same step, you go on for the B part. So the B part is means this one. This one. So it's the same method because they are connected in the series. Okay, so I'm going to have, okay, Miss going to write as a C total for the B part. It means for this one. So I substitute the value directly. Okay, which is stand for 1.25 micro, calculate with 1.7.5 micro. So I will get answers here. Okay, I'm not going to specify what answer. Maybe I put X, Y, Z. Example, just I'm not going to write for you the answers here. You define the answer. So once I done for the B sections, I go on with the C section. Okay, I wrote here as a C section. So it means this part, the C1. I'm going to use the same step. So one I did the same step. capacitance total for the C. So it means 1 divided by 1, okay, which is 0.35 micro. So 0.35 micro. Don't leave it your answer, even though the unit they given to you the same sum of the student. Sometimes when students do a calculation, they try to ignore. Means because their unit are the same, so means I ignore the unit. Don't do that. Every time take note based on your unit. Even they give you micro, they give you nano, pico. Take note based on your unit, because even if you not use the unit, sometimes your answer you provided at the end will be the wrong answer. Okay, based on the power. So okay, you done 1 divided by 0.35 micro plus with the next one where you have 0.86 micro. So 1 divided by 0.86 micro. Don't forget your unit, so you will get an answer here. So maybe you get a maybe you get PQR. This is not a real answer, Miss just wrote for you. So once you're done for the section A, section B, and section C, once you're done, remember when you see the circuit or the way you read the circuit here, you can see parallel. If you have a compared to your parallel, how does it look like? It should be in this form. So it means all the one you did in the series will be here. So it means this one will be, okay, this one stand for the total of your A, this will be your total capacitance for the B, D will be total for your TC. So since it's a parallel, you need to know what the equation that you need to substitute. So go back to your slide, find out for the parallel. So this one is for the series. Okay, let's go for the parallel. So parallel means you need to add all your capacitance. You need to add all your capacitance value. So from here, you add everything. So at the end, okay, example, the next step, okay, it means you're going to add to find the overall of the total capacitance of your diagram, this diagram. So it means you're going to have C total A plus with C total B, you're going to plus with the C total C. So it means any value that you get from here, example, Miss wrote ABC, right? It's not ABC, just ABC. The next one I just wrote as a XYZ, the next one PQR. So you need to specify how much the value that you get in terms of micro or in terms of nano. Okay, example, I put microfarad. Okay, microfarad plus with the microfarad units. At the end, you will get the last answer. Okay, do anyone get the last answer right now? Based on your calculations? Series 285 parallel 51. Okay, the total answer. Can we know the total answer? Is it the total parallel is the total answer? Okay, since it's going to be 610. Okay, only one student respond. Only Tong responded. How about others? You are able to get your value? Okay, all right. Means I already sent. Okay. Oh, edit. All right. Okay, Lin sent. Lin with 20.87 microfarad. Okay. All right. Okay, because when I see the Microsoft team, I only can see Tong's answers there. Okay, now only I realize on top of him they have other answers. Okay. Okay, 20.85. All right. Okay. You don't need to specific series and para. The one you need to specific the total answer. What you get the total answer once you add everything. This one. After you did series and para, get the last answer. So that's the one will be your total answer. Okay, so for today class, I will stop here. Okay, don't worry, I will take your attendance. Attendance. Okay, let me stop record here.